Welcome back to Duro3 YouTube channel. In today's video we're having a look at a controller I'm building up to go with a Emotator 1102 rotator. This controller is going to have a RotorEz PCB controlling the rotator. This is a PCB designed by Idiom Press and sold now by Ham Supplies in the US. So I got this board off them and I've adapted it to work with an 1102 rotator, and presses are doing that. I've got a few changes on this controller. So the panel meter is from a different version. I've just used this black one that I've got a hold of. I'm using the hot and push button for the on-off and the potentiometer for the dial preset in this. And we have brake operation and start, and right and left we have LEDs in here. Right and left we have a status LED and we have a brake LED. This display is illuminated by LEDs, three of. I've actually replaced the original switches in this controller with ones from a later version controller, so I've done that. It's got my new little, if it stops flaring out, you can see it, stainless steel plate that goes on here, and if you can read the writing on there, so in the background, you can see there's writing on the on there. It's been laser cut and etched at the same time. So this board has dial preset, brake delay, have whole hordes of things, and it works really well because it uses the maths processing in the chip that they have here. So it's a very nice board, and it just bolts to the back of your panel meter. And I've adapted these sort of PCBs for a few different rotators now. Even a Kempro KR2000. I've done several Kempro KR600s. I'm working on another one soon, which will be one for a computator. I've also done the high gains and CDEs as well. So the 1102 Emotator runs 100 volts on the actual motor. So I've had this transformer made by Star Delta, which is not far from me. 100 volts out, 240 volts in, and basically it's all ready to go. I've actually installed some, and folded the legs over, put in some clinch nuts, and I actually double clinched them. So yeah, and I'll be putting in just a single voltage transformer, 500 VA, 500 milliamp for the display drive. Now the back casing housing was re-zinc plated after I cut out the IEC socket. I've also had the holes done for the earth bolt. This is a cover plate, stainless steel cover plate. As you can see, it's numbered. If you stop it from flaring out, it's numbered, and this suits the cinch plug, and that just bolts straight on, and I'll put the old earth bolt on there. So this is a fused IEC socket. So that all got re-zinc plated, and so that's all in really good condition now. It wasn't before, but it is now. And the casing, I have had glass be blasted and painted, and basically, so that's all ready and raring to go. So I'm going to start reassembling things and getting things happening, but you can always look up RotorEz PCBs. They're not a bad PCB. You can adapt them to a number of things, as long as they only do just about 360, just over 360 degrees, 365 degrees. They can't handle any more than 365 degrees. So you can't use them on other rotators that do 370 or whatever degrees. So basically only designed for basically just 360 degrees, those ones, because the the high gains only do 360 degrees, so basically that's what it is. So basically I've adapted these to work, and I can get them to work, and I'll put in a little updates I put in here for making ease of the lining. I've actually replaced their single turn pots with 10 turn pots for doing the alignment. This makes things just a little bit easier. So yeah, so it's all good. There we are. There's the name hidden red. Focus. RotorEz, and this is version 1.4x. There's another version. I'll be doing has all the RS232 stuff sitting in this point, and has a slightly different chip. So that will be my next one I'll be doing. But yeah, so we're all moving forward. So we shall do a couple of little short videos and get this thing all assembled up and everything. Okay, we shall catch you next episode. Okay, we're back. Righty-o-ty. I have now installed the two transformers into position, and I've pre-wired the actual IEC socket. It's all bolted down, as you can see. I've actually got to do the wiring next, but I've got the little cover here out of the road. As you can see, the little cover there. The road, I've actually already wired the wiring to the socket and the earth bolt into here. So I'll be doing the rest of the wiring shortly. And so yeah, I just thought I'd show you that. So yeah, I'll do some more updates as we go along. I had to do some minor updates to here. Since this board was already wired when I put it on here, I had to do a few little upgrades to it. A loop wire in here, because then it has to go through the brake solenoid, the brake relay. So you can't drive it without pressing the brake first. But in the dial preset, it's all taken care of automatically. So just something I had to physically update on this. And I've already wired the 240 wiring onto that for the first part of it. So, and I cleaned up the wiring down here a bit too. Had to put the final wiring in for these, and I actually did a double stack here. I put the wires in from one side, each side on the board here, so it's a bit tidier. So one wire going to the output, and then this one goes down to the switch, so I haven't got wires going everywhere, so I've got less wires going everywhere. So I've just physically pushed one in from the top and one in from the bottom on on these two here, and other ones have got two wires in the one hole, because the holes are pretty big in these. So I also replaced one of the feed wires, which was only a smaller wire, because I was only dealing with one thing, and now it's dealing with two things. So I've increased the size of this wire to the next size up wire. It probably doesn't need it because it is 100 volts and it doesn't draw anywhere near much current as the CDs and high gains do. So basically I just did a few upgrades and whatnot, just tidy things up a bit more. So yeah, so there we go, another update. I shall be assembling this to that shortly, and I'll be back. Bye. Rightio, we're back again. Okay, I've just finished wiring up the pre-wired stuff, as in all the stuff on top of the PCB here, and I've installed, oops, I haven't got enough hands here, I've installed ferrite beads onto the 3 wires from the potentiometer. As you see, all the wires are in for the AC in. This is a neat little connection, this one. You can actually do it two ways. You run your wires in through the holes, or you can actually open it up and makes a much neater job. I'll try and hold it up. So you've got a screw terminal block in the bottom of it, and just pivots over and you can snap it back on again. It holds all the wires down, so I'm going to use that feature on that one. So I'm just about ready to stand this up like that, and up like that. I'm going to then finish off all the wirings, like the wiring for the power supply over there, the 2 wires for the power supply. I'm going to wire the main power in for everything for the 100 volts, and basically I can then move forward. Catch up. Okay, we're back. As you can see, I've now got everything, all the wiring done, and the whole thing's been 95% assembled. I'll clean all these bloody finger marks off the back here, jeez. Okay, I had to do a little mod to as well. I had to go back to the original pots in these, but I had to put them at an angle to get over the IC down here, and plus make it easier to get to them on an angle. So I put the original ones back in again. The 10-turn ones were just a pain because they're on an angle. They have to come in from the back. So I went back to the original ones. Well, the original ones that come with this one were they were around the other opposite way. So I replaced them with some of the original ones that I had a few, which I took out one night when I did them before. So yeah, so there we are. So it's basically ready to go. There you go. So what I was going to do, I was going to show it partially working. So what I've done is I've simulated a rotator, a 1102 rotator. So I have the solenoid brake, the 100 volt motor, and I have the top part of the housing with the potentiometer, and I have a plug and the motor start capacitor. So what I'm going to do, I'm going to show you this working since I haven't got the rotator done yet. So I'm going to basically plug in my IEC power lead, and then we'll put the potentiometer on this side. Also wired up the brake on this one with a plug-in terminal because they're a pain to get in, not in normal situation. So basically I'm just going to plug him in the back, get this over top of that wiring there, and then we can show you it working, sort of like. Let's untangle everything. Hopefully we can see everything. You won't see all the lights going because it's a bit bright here. So we shall see how we go. Righty-outy. Make sure nothing's hitting anywhere. So we'll turn him on. And that'll always go to the full right-hand side. It's a part of this setup procedure. Now at the present moment, the green LED is on, and that will change colour to red when you turn the preset set turn to red. If you don't press the brake, it'll just go back to normal position. So basically, and then the brake light here, so you can see the brake come down, and the brake light is on now. The direction switches in manual mode, the LEDs for the direction switches only works in preset. They do not work in these ones in manual mode. So we won't see them working at the present moment until I physically do a dial preset. Okay, so I'll show you the dial preset. So I'm going to use this as the get that untangled. So basically east is this way, west is that way, south is down here. So if you can see what I'm doing. Right, so east is this way, south, we're at north at the present moment, west and down that way. So if I dial up, let's say we dial up west, so we're dialing west, and it'll move to west. We press the start button. Now the blue LED will come on, which you can only see, and if we just start dialing or turning the actual pod around here, see the needle moving, it tracks it. At the same time this LED is changing colour from red all the way back to green again. And when it gets to down here, you see the blue light go out, the relay clicked, and after 3 seconds the brake will re-engage. And the same thing applies. And let's, if we go back up to north, we press the start button, the opposite light comes on, and that LED will be changing colour. Be good to show this in real light, and then the blue light will go out, and 3 seconds, it goes out 3 seconds before it reaches its destination. There's a whole lot of settings you can do on these, and this one is actually set up to do 3 seconds prior to reaching its destination. It removes power from the motor, and then the motor can then coast to its position, and then basically the brake is engaged after 3 seconds. So there we go, that's a brief run through of this. In manual mode, you can see it working in manual mode. I'll show you it working in manual mode. So the lights don't work, but the brake light does work because it utilises through the circuitry. So we can push the brake in, and we can see the motor spinning over here. We can stop and start as much as we like. Go back the other way, but the lights don't work. It would be nice to have had the lights to work, and it is what it is. And then after you release the brake would disengage. There we go. Rightio, okay, that's enough of this. I shall be putting this aside for now, and then basically we will come back to it when we have the rotator all assembled, or as we go through. I'll go and do another video with the rotator, so the 1102 rotator, which we'll be doing eventually. So that's this one up and running, and at the same time I've been doing a second one of these for another rotator to come up. So I've been doing all the board and the updates and bits and pieces on the same thing. It's all the same wiring layout and everything, so I've been doing that as well. So it's been a double hit for me, so I'm just trying to do two things at once because it's the same board. The other one will have dial preset, will have a remote control in it. This particular board doesn't have remote control. So we shall catch you in the next project. Bye.